Alright guys, sorry for the awkward silence. Um, this is gonna be the first proper kind of Friday live stream open studio kind of session. Um, Unlike yesterday's video or stream, today I actually have a plan. I think we're gonna try and create a rapid prototype today. And just see how it goes. This is completely unscripted. I'm just kind of doing whatever. And hopefully you guys get to see some of the process behind making these planes. So let's get our materials out. So have scissors, a ruler, X-Acto knife, a pen. What else? I got a compass here. You guys can't see all of that, but here are some of my tools. Second ruler. And that's always useful to have two rulers to be able to fold things. I guess I can show you guys. Basically, you can pinch the paper with two edges to make a very straight fold. It's a technique that I learned from this other guy. He makes really nice 3D models that he sells. I think it's like Master Paper Crafts or something. It's been ages since I've visited that site, but he does his own 3D models and puts them on a website for sale. So if you're interested, you should check it out. But I learned that, the two ruler folding technique from him. So yeah, let's get some paper out, start designing a rapid prototype from scratch. Just starting off with some sketches, I guess. Let me just grab some paper real quick. The requirements for this aren't that much. You just need a blank piece of paper and I guess a rough idea of where you're trying to go. For this rapid prototype, I want to test out some new techniques, probably. I don't know how else to put it. But if you saw my live stream yesterday, the test live stream, I was explaining how I was having some trouble developing the rest of the fuselage for the next version of the Astra, which is right here. I was wondering how to kind of finish off the aft portion here, kind of build in this cell. I might not actually do that now that I think about it, but I definitely need to figure out ways to mount the vertical stabilizer, because I want it to be aft of the main wing. That way, when it's at a high angle of attack, it'll be receiving fresh air from under the wing. And that's a concept I got from RC something Power. Their channel has been around for a while, but all their high alpha performance planes, so planes that can go up to a high angle of attack relative to the air, always have vertical stabilizers in the back behind the main wing surface. And that's just to be able to have fresh air, act on it so that it's stable. So to I guess further this long-term project, I'm looking at making a new rapid prototype, which is what I'm gonna try and do here. So I have kind of a rough concept. Don't know if this camera's set up right. Let's see. All right, yeah, the paper is mostly in frame. All right, so I guess we can just start. I don't know how long this is gonna go on for, but if you want to stay on, you can. You can work on your own projects. This is meant to be kind of a casual thing. Mistakes will be recorded and uploaded eventually, so it is what it is. No editing. All right. So I think I'm gonna start with. Well, actually, let's see if pencil shows up on the. 'Cause I'm not sure if you guys can see this because pencil is light sometimes. So I guess you guys can see, but yeah, I think maybe using pen is better here because it's darker. Except it's more permanent, so really just can't hide any mistakes. So, but yeah, I guess we'll start with pencil, just see how it goes. I guess you guys can see it. Nice thing about pencil is there's no flow issues. The lead is already there, basically. So you can't really go wrong unless the lead snaps, but then you just get more lead. With ballpoints, it's kind of hard to predict when the ink is going to come out. That's why, you know, in this case, probably going to go with pencil. But yeah, pens are great too for designing, especially ballpoint. I didn't used to be a ballpoint fan, and that's because it's just kind of weird. Like the feedback is smooth, but it's, you know, a lot of friction, and then the ink isn't always consistent. So I'm just starting out with kind of a rough concept sketch. What I'm doing here is kind of an isometric. It's not exactly isometric because isometric means you have a cube basically, and you're basically looking at it from the corner straight on. I'm not sure if you guys. Yep. Yeah, that's pretty much it. So that would be like a true isometric. There's also other types of drawing, I guess, but we're just going with a rough 3D conceptual sketch here. So this is going to be the main axis of the design. Yeah, not much else to say here other than it's a diagonal line. Usually, because I'm right-handed, I draw the nose on the left and tail end of the aircraft to the right. You can go the other way. There's nothing stopping you from doing that. It's just I'm right-handed, and usually that's how the convention goes, is you go from left to right, just like when you're reading a book, left to right. The nose to tail. That's just kind of how I set it up. I'm doing this in landscape because that'll allow for more, I guess, wingspan here. So if I did it in portrait mode like this, you don't really get a lot of room for the wings, So I just find this to be the most comfortable way to set it up. So once you have this axis here, you really just start sculpting the design. I don't really know how else to explain it. I mean, if you're playing as a flying wing, this might turn out to be different because you start to draw directly the wings. But I think even in that case, you would still have to draw a kind of center axis, unless you're going with an asymmetric design like one of Burt Rutan's designs where it's like a wing and you know, you have like a partial thing right here and a fuselage here, which honestly I don't understand. It's very strange. Uh, and you know, you have like two propellers here. It's just so weird design. So we're not going for any of that, you know, stuff. So just get an eraser real quick. Let's get rid of that. But yeah, so just gonna do that, and then, you know, this is gonna be the wing main axis. So it's like if you have an airplane like this, basically, we're drawing this direction right here, right? And because it's in 3D, that line is going to be skewed. So it's going to be at an angle to this main axis, right? And on 2D, these four angles are not going to be right? They're actually less than 90 degrees, but they're representing this 90-degree block right here. So I think I'm going to erase this too, just to, actually, you know what, I'll just leave it, whatever. If it gets in the way, I'll erase it, but for now, I'll just keep it. Just clean up this markup right here. So you have your main axis, your wing axis. For this design, I don't know, I'm just gonna go with something crazy. You usually see forward swept wings with canards, so I'm gonna try and explore a design where you don't have canards, but you know, like a regular aft of the wing control surface. So just kind of have to imagine the fuselage here, right? You can definitely mark things up. It can get as complicated as you want it to be, which is kind of this entire interest in general, is how much effort do you want to put in. But I don't have any stencils, so this is going to be kind of a freehand sketch. But essentially, you're going to have to draw, if it's a circular fuselage, which I'm just going to use a circular because it's just easier to draw. It might not be the actual prototype, but you just kind of put down some light ellipses. So, and then this is going to be the vertical axis, the yaw axis. Okay. So you have your three axes in 3 dimensions. Draw a circle like this. And draw several more. There's definitely like more just stricter rules regarding how to draw these ellipses and how to align them. But that, that's like a little too much effort for a concept sketch. So, I mean, it's supposed to be kind of a loose, casual process. This is kind of a live stream session, so I'm just gonna put down some fuselage contour lines. So you're just drawing out the fuselage here. This is pretty boring, and yeah, it's just a plain cigar shape kind of a fuselage. But with these curves, you want to try and meet with these points where you're trying to, I guess, create the surface, which is basically a bunch of circles, and then the surface that connects them. So you can definitely practice this on your own time, or follow along, have this stream in the background, and listen in. But each of these smaller ellipses, or yeah, have their own, you know, 2 axes too, right? We just started with the overall long axis and worked our way from there. So when you're designing these things, you also have to think about how you're gonna make it. I know for me personally, making round things with paper is not a really easy thing to do, because paper literally only likes to fold this way, or you know, basically you have one axis where you're allowed to fold. So making some concave shapes like this, where it's curved like this and like this at the same time, is really hard to do with paper. So usually I draw it in representation like smooth shape like this, but in practice I usually make pretty angular designs. So if I pull out some examples, for example, this is the Rapid Prototype 003. This is as curvy as it's gonna get. It's really hard to contour, you know, like, so like if you look at this axis, it's pretty straight. It's not curved, unfortunately, and that's just due to the material properties that, you know, paper has. I know there are some modelers out there that cut slots into like into pieces like this, and so they're able to, you know, like cut on the sides here to make it bend in the other direction too. But you know, I like to keep things simple, and so whatever the paper decides to, you know, take shape as, you know, it is what it is. So but you know, like I said before, it's as much effort as you want to put in with regards to this interest or hobby. That's like another weird thing. Like, this hobby is not really a hobby. It's more like a, you know, self-experimentation. It's like it's not RC. It's not quite, you know, at that level where it's radio controlled and powered. But it's also not just like regular, you know, Nakamura lock or, you know, schoolyard, you know, dart paper airplanes. It's like somewhere in between, but you know, it's like a difficult thing to define. But kind of throughout the years, I've kind of set some goals for myself, which is to experiment with new ideas and whatnot. So I'm ending this fuselage right here, just kind of sculpting it. That's the nice thing about pencil, is you can use your eraser to sculpt this too. As you can see, like, this would be a type of design where the aft of the fuselage comes up. So like in a standard commercial aircraft, the aft of the fuselage tapers up, and you have your, you know, your tail surface, right? And so that's kind of what I'm going for, but I don't know, I'm just throwing out ideas and just trying to sculpt some interesting shapes. But yeah, the fact that it tapers up means that it's going to go off the center line. So it means that this, you know, line is probably not going to go through the center of this ellipse, right? And so I'm just going to clean up a little bit of the lines here. Yeah, so that's a fuselage. Not sure if I want to keep this, but yeah, I think this might be a little too long of a taper, so we're gonna reverse it a little bit, sculpt this back a little bit to its original shape. You can play around with, you know, the lines here. There are definitely tools out there that can help you with drawing these shapes. Let me try and find if I have one of those, but I tend not to use many tools. I just like to freehand things. Just simplifies the whole process. But there are, you know, French curves, which are, you know, these tools with like these massive amounts of like curvature, like, you know, you have varying degrees of curvature. It's a stencil basically, right? And you can trace your curves along the edges, you know, but we're not really gonna go with that. But that's definitely a thing. In practice, when I actually make the designs, I just tend to use whatever naturally occurring curves come out of the material itself. So if you know, for, you know, my actually pull up the prototype right here. So generally speaking, I just let the material do its own thing, and so you get a really nice curve. Sometimes when you draw, the curvature is like, for example, it's like curvy here, but it's like flat in between. So it's like, what's really happening there, right? But if you let the material naturally deform and just constrain it at several points, you can get a really nice curve. And the method behind that is, I mentioned it in a previous video. It's partially inspired by old shipbuilding techniques, and basically the idea is that whatever shape it's gonna take will be the shape that minimizes the amount of energy that's, you know, in the deformation of the material. It's a bunch of science talk, but it's essentially what nature intends it to be. If you think about it, that's literally everything in the universe is whatever nature intends it to be. So I think I like this. This is starting to look a little bit more reasonable. So what I'm doing right here is I'm going to add the wing, kind of a cross section. Of course, this is in a 3D kind of view. So I'm going to do the other side too. So you can kind of see like the extrusion of this airfoil-like shape through the fuselage. God, it looks a little bit messy, but I'm putting on the side lines here that are going to intersect this edge of the, you know, the cross. And you can erase these lines later. They're all kind of construction lines at the moment, so it helps you visualize what you're actually doing. So here, I'm going to go with a forward swept configuration. So I usually start with the leading edge. Yeah, and you can feel free to like use a ruler or something to help you, but I tend not to rely on it too much. But it is what it is. So I'm gonna leave the wingtips like it is right now. Try and rough out the shape on the other side. you might find it easier to rotate the paper itself to help you get a better angle. This is like where it gets hard when you're just purely eyeballing things, is to see if it makes sense, you know. Like as in if it matches on the other side, which, you know, the shapes are gonna be different on paper, but does it feel like it's the same shape on the other side, right? That's what you're trying to check here. Essentially, you can continue checking by doing like a cross line here. So you know, the other wing here, the right wing, because this is forward. The right wing looks to be a little short because it's intersecting this line. So it's currently at this point, I'm gonna move it out a little bit to make it look more plausible, I guess. And I marked 2 points to test out. This point right here, and this point right here. Gotta clean up a little bit here with eraser. Yeah, you know, this process is not exactly linear. Sometimes I look at something and I'm like, oh, this is interesting. Like, what if instead of just truncating the wing here, what if we had like winglets, but instead of going up, because that would look weird, you know, forward sloped winglets with, you know, the surface going forward. What if we had to go down? You know, kind of like the ASFX Shinden design that I made a while back. So you don't always have to, like, you know, if you're stuck on one section, you just ignore it, go to another section, work on that, and then come back to that. But then you also have to remember to keep like an overall perspective of your entire thing, right? So yeah, this is gonna be kind of more outboard, I feel like. Maybe the starting point is a little too, yeah, so this is probably gonna end here. So a lot of this is coming down to eyeballing. I mean, this whole process is kind of casual and eyeballing. You definitely can CAD. This is only one way to do it. You can definitely try and experiment with different methods in your own designs, but this is the way that I like to really kind of visualize the design. Right, this is about the same. Depending on what kind of perspective you're doing, it's either going to be the same length or not, but I usually just eyeball it. If it looks about right, probably is. It's fine the way it is, and you know, this is a preliminary sketch. So, and with the wings too, you can sculpt, right? Like that line, it used to be out here. I just drew a line slightly more in to make the wing more slender. And you know, you can use an eraser to carve out that unwanted line. So it's really like a knife of sorts. It's you know, that's the nice thing about drawing, is it can be additive and subtractive. You put stuff down onto paper and you can erase it. So this is kind of like machining away the actual surface, right? So this is interesting. Doesn't look quite right. Maybe it's because I'm doing it on camera live, but let's try and get this to look right. So let's sculpt the body down a little bit. Maybe sculpt this up. And the aft fuselage a little early. Sharper taper. I'm thinking about this design right now, and I think because the whole intention behind this was to, because new people are constantly joining, so I'm gonna have to repeat myself, but I want to be able to add a vertical stabilizer to the end of this new version 2. I'm gonna call it M1 probably, the YX10. So I'm gonna try and figure out like a way to mount vertical stabilizers. That's kind of the goal with this project. I don't know how good of an idea I'm gonna come up with on camera, but we're just playing around, I guess. So let's move this outer edge a little outwards. Use the eraser to sculpt out that more slender shape for the wing. I'm thinking about it right now, and I think it would be nice to have like a kind of a curved winglet. So like instead of like a sharp fold, you know, like that, where you end your wingtip like that. I'm trying to go with a design where it's more like, you know, you end it here, but it curves down smoothly. So this is kind of nice. I'm not sure how I want to do that. About manufacturing. How am I going to make this? So I need to change the cross section here, change it on the other side, because I just shifted it a little bit. Erase that old line there. I'll just sculpt this out a little bit more. Erase kind of the bits here, because the wing is actually what you see and not the cross section. So this, a lot of it is construction lines, so they might be gone by the end. So I want to go with this kind of a design, but how am I going to get that? The only material that I know that can form this unique shape is really a paper clip, maybe. So you can have like a, I don't know, tool like this, and let's see, where's a nice curve. You could probably place it down like this and then try and force the paper clip to conform to part of this curve. But that's just an idea. So if I were actually going to do that, how would I, you know, really integrate that paperclip into that wingtip design, right? That's kind of a good question to think about while you're sketching. Because I think this, also a couple of things have turned out. We're gonna go with a winglet, downward winglet that's smooth. This is probably possible with, so I use, what is it, 165 gram per square meter cardstock. So I think it might be possible to, you know, first fold the paper like this, right? You just close that down, and then after it's like relatively flat, and then, you know, you curve this edge down so that it becomes like this, right? But it's like still like there's a little thing in between that is the paper clip wire. It's gonna like wrap around here to create some rigidity. Don't know how far back I want, you know, the wire to support, but anyway. See, I go off on tangents. That's kind of the way I operate when I design stuff. Just think about possibilities and really just let your mind go loose. Oh yeah, so I need to copy this on the other side. And it's kind of like, you know, you might be wondering like, how do I know what to draw? And this is really just comes down to practice. You know, you practice drawing, I don't know, like ribbons, or like, for example, if I have like a strip of paper and I've put this end to this end and it's a cylinder, how might I draw that cylinder, right? You have one edge here, and then the top and bottom edges here, and then the aft edge there, and then you still have the front edge, but this edge on the back technically continues through here, if you can envision that, and here it actually comes out, right? So it's kind of like that kind of a shape. And essentially what we're doing with this winglet is we're taking a part of this, right? Well, imagine like this goes, you know, continues on, but, you know, same idea. It's the same kind of shape, so practicing these basic shapes can help you draw like a winglet. Anyway, so here it's like, okay, well, this edge is going to come down past this, if you can envision it, right? It's going to join this edge here. Okay, maybe that's a little too steep. I'm going to keep this edge here. So, yeah, I think that's okay. Might look a little bit off, but no worries. This isn't like a final art piece. This is like a concept sketch, so it doesn't have to be perfect, but it definitely does help to keep practicing your technique for visualization here. Yeah, just thin out that edge right there, round it a little bit, because it's not just the front edge that's going to be round, the back edge, if it continues, it's going to be round here too. That's a neat detail that, you know, like when I design, I look for these kinds of details. I think it's really nice and beautiful. That's why I kind of pursue these ideas. And then you have to be able to express it somehow by drawing, right? That's like the next stage from your brain to the paper. And then eventually you'll have to figure out a way to actually make it from paper sketch blueprint to reality, right? So this is going to curve back. And, you know, again, with these concept sketches, it doesn't have to be perfect. So this is looking a little bit thin compared to this. I'm now just realizing. So widen that curve a little bit. Alright, sometimes you just start from 0. And try and get it, but this is proving to be a little more troublesome. Again, there are definitely ways, proper ways to do this, but instead of spending hours perfecting the geometry on paper, I'd rather get the concept down on paper and then get a 3D model going. This is a little too much outboard. Let's correct it a little bit. Correct it a little bit. to just leave it as is. Sometimes your first sketch looks better. It's like your intuition makes it a little nicer than what looking at it and trying to fix it does. So I don't know if that made any sense, but alright, whatever. It is what it is. I'm gonna clear out some space here. Clear out that label because I know what it is. I'm trying to get rid of this cube here. Get rid of this example fuselage. It's kind of a warm day today. Temperature is outside. Nice, 66, almost 70 degrees. Wow. All right, so still looks a little bit off, but at this point, I don't think I'm gonna fiddle with it too much longer. I'm just gonna make one final edit to this side because I know that side is gonna be a little finicky, at least for me, to draw and fix. So I'm gonna cut this wing a little more and just slice off that trailing edge right there. Isn't that nice? That's like so oddly satisfying, right? It's like machining. You're watching material get removed. It's really just easy as taking a pencil and an eraser and then erasing the lines that you made. Alright, so now for the actual fun part about this design, which is the tail surface. I think I'm gonna go with a twin boom. Okay, I'm sorry, this is really just bothering me too much, so I'm gonna have to tinker with this a little more. Undoing all the work that I did. Right, looks something like that. Alright, I keep the lines light. That's a generally good idea. But I have trouble doing that. When I was a kid, I took drawing classes. My teacher would always complain to me, Ben, why are you like using the pencil like too hard? Why are you pressing down too much? Because what you do when you do that is, paper is made out of fibrous material, and if you draw too hard, it's going to crease the paper, and you literally cannot get rid of the marks because the paper has been crushed, So if I do that, you can see that the paper, it's deformed permanently. But if you draw light, that's not a problem. You can still erase. I know like a lot of people like to draw with 2B and think that that's the reason that they can't erase. That's really not true. Softer leads erase nicer. It's just you're pressing too hard onto the paper. So try not to do that like I did. So anyway, it's just a nice drawing tip. Yeah, so this looks alright. I'm gonna start and get rid of some of the construction lines. I feel like I might be getting in the way. And this is like, relatively speaking, where I want to place the booms heading back. Probably gonna do a twin boom design, so just sketching out concepts here. this is exactly similar to the wingtip and that cylinder I was drawing earlier. It's exactly the same thing, but on the vertical stabilizer. So definitely practice basic shapes if you want to be able to do this. That's a nice thing about using pencil. Did I make a mistake? You tell me. You know? Yeah, this is gonna be a nice edge here. If you look at like commercial airplanes, at least on the engines, you know they're not like a sharp lip, you know. So you have your engine here, but then the nacelle wraps around it, and the inlet lip is like a round leading edge structure. So I actually have that kind of a thing going on in the Rapid Prototype 003. I put a straw in the leading edge and then wrapped the cardstock around that to form like a blunt leading edge. That's just for looks, obviously, but in real life, that round edge does help air intake. So you're like when you're turning a little hard and it's not, you know, the air is not coming directly onto the, you know, the inlet. If it's sharp, it's gonna separate the air. The air will be like, oh my goodness, where did, you know, the inlet lip go? And then it'll just like tumble, and then the engine will suck that in, and it won't be a good time for the engine. So, you know, that's like an aerodynamic theory, is that you want to keep the leading edge, at least for subsonic flight, you want to keep it blunt so that air doesn't separate, right? So you want to keep it round and nice. For this second version of the Astra, I actually incorporated leading edge slats, which are, you know, they're like really sharp, but essentially I have this mechanism on the bottom that allows you to deploy them. So right now I'm stowing it, but you pull this bottom knob back and it deploys the slats. I don't know if you guys can exactly see that, but deploying the slats while you're in a turn angles your wing so that it's aligned with the incoming air, so it doesn't separate and you don't stall and lose control. I think it's just a beautiful detail in, at least for fighter aircraft, when you're, you know, seeing like an F-22 turn really hard, their slats are probably pointed down, you know, as well as the F-16, F-35, and, you know, most fighters which have very thin wings, you know, their cross sections are like really thin. They have that actuation mechanism to help them turn better in a dogfight or whatever. So it's just a tiny detail. But anyways, I went off on a massive tangent there. But this is nice. I'm trying to get that rounded inlet lip structure, just like in the engine inlet lip, onto this structure right here. So like these are the things that I think about. It's like, how do I join this A-tail configuration? You know, you have your wings, right, your body, and then like a A-shaped tail. How do you join it, right? And I honestly have no idea, because I did it once where I think it was like Rapid Prototype 001, where it was a twin boom design. So we're revisiting that, but instead of a delta wing now, we're going with a forward sloping wing. So it's, you know, like, how do you join this nicely? Because in the other design, I had like a twin boom configuration where it was just a straw, and the A-tail was essentially a piece of cardstock with the end wrapped around here, you know, kind of like that, and then this section is taped down so it doesn't let go of this. That's not very, that's not a very secure design. I'm trying to figure out a better way to do that. The problem with straws is that their manufactured tolerances are off sometimes. The straws could be bent, they could be a little shorter than one another, so I just would like to not rely on a straw structure to get this boom going. So how are we going to make this? That's a question that I am wondering to myself. And how is this going to join up with the boom? Right? I think it would be nice to have like a nice, I'm saying nice a lot, I'm so sorry, like a swept fillet kind of connecting the two, so it's like super aerodynamic, right? And then it's like, how do I end the vertical stabilizer here? And that's another good question to ask, right? So I think I'm gonna give them little tabs here. I don't know if that makes any sense at all. So from the top, it would look something like this, but then only this section is bending. Actually, that's a neat design. I think I might actually do that. Well, you could keep it sharp. I don't know why you would want to do that. That looks a little weird to me. Well, then if you have it sharp, then you might as well just cap this off, in which you would just end up with the original design. But I am liking the idea of keeping it like this. Maybe not like a sharp corner, maybe like a round corner like that. So like a round control surface. I have no idea like what that's gonna do for the actual air that's gonna flow around it. I have no idea. I am not a computer simulator where I can see air move across surfaces. Some really good aerodynamicists and engineers are probably able to do that, but I'm more of a structures guy. I mean, that's my job. I make sure things don't break is basically what I do. So let's see if there are any comments. I'm sorry, this is like my second live stream ever on YouTube, so if you guys have any comments, I don't know how to see them or access them. Oh, nice. What is going to support your tail? Drinking game, take a shot every time he says eyeball it. Good job. Nice. Yeah, you'd be pretty drunk if you want to take a shot every time I say eyeball it, because 90% of what I do is eyeballing. So anyway, all right, so whoops, my bad. Yeah, all right, so I just looked at some of your comments. I think it was Pep Rockets. You're gonna get drunk if you take a shot every time I say eyeball it. So I think I'm gonna leave this sketch. This sketch is really nice. It's it kind of shows what's happening at the back here. This is like a sub sketch within this overall sketch. So I'm gonna leave it. But yeah, you look at like Da Vinci's notebooks and things like that, which are great sources of inspiration for me. He has like tiny sketches off to the side where he explores a certain idea a little bit more. I know like I've done that for other features in this particular design, but I've kind of erased all of them. So and that's because I needed space. So it's all for good cause. I'm gonna clean up the line work around this edge right here because it looks kind of cluttered. Let me see if I have my tools. I have like a nice sticky eraser that I like to use. I'm struggling to get it. All right. Nope, it's not in here at all. All right, I have no idea where it is. All right, got it. Problem solved. All right, so this is a nice sticky eraser. You might see like electrical tape wrapped all around it, because that's because it kind of broke on me. So I had to make my own handle and like keep the plastic together. But essentially what it is there's a clutch and the sticky eraser is there, and you know, it's like a pencil, it's like a clutch mechanical pencil, but it's an eraser. So I don't know exactly what model this is, so I'm not gonna be able to help you there, but they're definitely available online. So that's, you know, like a precision line work. I tend to go with this. It's easier to erase than using a block eraser like this, which is super blunt. So yeah, I'm just gonna end that and fix the line work here. Ow. Alright, so this is gonna end here. This is interesting concept. And I don't say that to like congratulate myself, but this is like genuinely something new. Like, I have not thought about this before. Like, I had a general idea of where I was gonna go with this design, but you know, so like the overall configuration, I did not come up with that on the spot. I had a general idea. I was like, well, forward swept wings, you know, they're great. They're always paired with canards. What if we tried a twin boom idea with a forward swept wing? So here we are. Yeah, so that looks interesting. I think I'm not gonna have like a sharp corner here. I'm gonna round this off. So, you know, this design is really organic looking. I think, you know, it's like one of Burt Rutan's designs. I don't want to compare myself to him because he's building actual airplanes. I'm just making glider models here, but yeah, his designs tend to be pretty radical, and I would not necessarily feel safe flying in one of them, but they are definitely cool looking. You know, like sweeping organic lines. If you ever seen the White Knight Spaceship One type deals, you know, they're super nice. Yeah, this winglet is really bothering me. Jeez. What if we just like faded it out? Alright, so it's there, but it's not too obvious. Anyway. Alright, so I'm going to start to get rid of some of the construction lines here. You're probably like, oh no, now it doesn't look as cool, but, well, it's not supposed to look cool. It's supposed to convey an idea, describe the shape. And construction lines, once you have an actual geometry, they don't do really much other than clutter your drawing. So I'm just gonna try and erase some of that. This is still a mess right here. I still need to define the boom shape, right? So this is like a nice round shape. Again, this is ideal. Like, in an ideal world, this is what the boom is gonna look like. But given our constraints, which is basically I only can use paper, and I can use straws. The type of straws I use are like this, and well, if you look at a rapid prototype, you see some of these orange, larger diameter straws, which, you know, are also available. So So this kind of a round shape, I don't know how I'm gonna actually build that. So this is like idealized. When it comes time to build, I think I will definitely have to do something different. Another idea I had for this boom coming back is like just like a flat panel of some sort. The problem with that is when you're high up at an angle, your plane is like, in this case, like a forward sloped wing, the nose is pointing up. If you have like a rectangular piece of material here, it's not exactly the most aerodynamic shape for the incoming air to like interact with. So I don't really feel comfortable doing this, but I definitely don't want to use straws because the variability in tolerances is just too much. Sometimes they're bent, sometimes the ends aren't the same length, sometimes it's uneven, and just like generally speaking, like I like to try and make things that you can predict the material, how it's going to behave. So with straws, I know because I've worked with them that when you have like a main straw in one location and you take another straw, right, and you cut out like a chunk here and you wrap this the thing right here around this, it's gonna end up with a little shape like this right here. So actually, this isn't the best example right here. So if you take a straw and you flatten it so it's kind of flat like that, it's like an oval, and then you wrap it around another straw. Why would you do that? Like that's a great question. I made a mechanism that involved this design as a bearing for this center straw right here. So the center straw is like a turning piece, and then this outer straw right here is like a flattened layer that wraps around. So if you understand material behavior, you can predict that the shape is going to be like this. You're probably wondering like it's just a straw wrapping around a straw. Like, what more prediction could you possibly have, right? So you have like a straight cylinder or straight straw here. If you wrap a flat extruded straw around another round straw here, you're gonna get this subtle detail, but it's a curve. You have to account for that because if you have like a output on this axle, right? So you have like an airfoil shape control surface, like a canard or something. You want to know how that curve is going to interact with this material. This is like super abstract because you're not looking at a physical example, but I'm just trying to explain from my experience. Knowing the material definitely helps. So I don't know like a great way to really integrate a round straw with a flat structure like this, other than wrapping the paper around the straw, and that's like, this is gonna shift back and forth, right? And when you strike the ground, it's gonna, I don't really know what it's gonna do, right? It's not the best option. I've done it for prototype 001, but I want to do something better here. So let's see. Right, what is going to support tail? That was the last comment from about 13 minutes ago. Yeah, so like a spar of some sort, but it can't be flat, and it can't be a straw. So what is it going to make? That's my greatest mystery right now to solve. Yeah, just going back to that winglet, fixing that. use this to clean up some of the lines here. I have been streaming for a little over an hour. I don't know how long this is going to be. Maybe two hours, depending on how into it I get, I guess. Hopefully it's going to be around 2 hours, 2 to 3 hours. But this is like a really nice way to sink your time into. You can go as deep as you want with this. Honestly, it's like, you know, craftsmanship is like a curve, right? So you have time on one axis and effort level on the, well, I guess not effort, but quality. And then you have a curve that kind of looks like this. So the more time you put into it, at first, you get a lot of gain. Then eventually, your quality is going to reach a certain level where it's like acceptable to you, maybe. This is more parabola, like so. So more time you spend, the better quality is going to get, but it's like a marginal cost problem where the amount of quality improvements decreases over time because this curve is leveling off. So you want to find that balance for yourself. For me, I essentially have unlimited time now, so I try and put more time into these projects, which is why YX10 M1 is being delayed, because I want to spend the time to get it right. I don't have schoolwork or anything right now, so I can spend more time to get the quality up. But if this is like a actual curve, I don't know like what the area would be. That is a curious question, like the area under the curve. So that'd be like dq dt, but like you integrate this whatever function. But it's been so long since I did any math, so whatever. But that concept, I think it holds true for any hobby, right? So if you practice music, it's always going to be like that too. If you cook or anything, the quality, your skill goes up really fast at the beginning, and then it levels off. Well, then again, there are like learning curves, so I guess it kind of varies on the individual person. But anyways, I'm gonna erase this to get a little bit more space. Alright, so we have a general sketch now. We got rid of most of the construction lines, and so now what we can do is, let me just tune the drawing a little bit. I'm going to leave these random sketches here. Maybe erase this one because it's boring looking. This is an interesting looking sketch. I definitely want to keep this. This is like the back end here, where we're doing that lip design. And this comes down. It's going to be like a nice curved design here. I don't know how I'm going to create this, but I want to try and aim for this. Alright, so clean up some lines, make this line a little softer, a little bit thinner. Lines, the funny thing about lines is that they don't actually exist. I might sound like a crazy person saying this, but on physical objects, like for example, take this pencil right here, you don't actually see a line at the edge, right? This is like one of those things that you learn in art school, or, I didn't go to art school, but in art classes, is that when you draw real life things, they don't actually have edges. So how do we express this shape, right? It's an interesting idea. And really it comes down to values, right? So if you take a picture, zoom really close, you're gonna see that, you know, an edge is a set of values against a different value, right? And how contrasty that edge is, you know, that's like, there's like a whole field of study, I guess, that studies that, but you can smooth out the edge, right? So you can have like a hard edge, like on a knife or cube of some sort, right? Like that. Or you can have like a rounded edge. And this kind of gets into shading a little bit, which is what I'm going to try and do next. Sorry, this is like supposed to be a design tutorial or live stream or studio or whatever, but I'm just kind of teaching you people how to draw. But it's definitely important. Don't get me wrong. Like drawing, it's great for visualization. But studying this, right, takes a lot of time. You need to practice. You can't just like watch a video and understand it. Actually doing it will help you learn. So yeah, again, I was saying, like, these lines, they don't actually exist on the thing we're trying to build. They are actually just surfaces where different values meet, right? So the magical thing about this is once we start, so we want this drawing to pop out a little bit, and since most of it is white on white paper, if we shade the background to be a little bit darker, we're gonna get this drawing to pop out a little more, right? And you're gonna think like this is not important to the actual design of the airplane, right? I mean, a lot of people think that. A lot of engineers don't care about aesthetics, right? A lot of technical people don't care about aesthetics. But I truly do care because it helps you convey an idea, helps sell an idea to yourself even, you know, in this case. So if you make it look great, it's like, wow, I really want to build that. And then you figure out like ways to build it and whatnot, but that comes down the line. Like, if you're not even inspired by your own work, that's like, why are you even doing it? You know, like, create good work, be proud of your work, make it look compelling, right? And so what I'm going to try and do right now is use this pencil and lightly sketch. And this takes practice because every stroke that I'm making is like right on the line, right? Of course, I'm not a machine. There are variances, but you can go with it too. But I find it harder to shade consistently going long like this instead of short strokes like this that are at an angle. This makes it a little bit easier. Now, if you're a fine artist, you have these tools called tortillons. They're basically, they're not tortillas, they're tortillons, which is essentially paper wrapped up into a cylinder and sharpened with a pencil sharpener. And the kind of like the fuzzy paper on the end of that raw, you know, cut paper is a great material to soften shading and like to smooth and blend everything out. I typically don't like to use that because I find it to be a little gimmicky, and quite honestly, if you use it a lot, your drawing's gonna look plasticky. I just like a little bit more texture in my shading. So this is like a light round, but then you can layer on top of that. You want to think about like where you're putting it. Doesn't make sense for me to put it here because that's not where the plane is. But you know, like these areas right here where you really want to make the boom, for example, pop out. Right? This is actually quite therapeutic. Just like sketching away, listening to the sound of graphite scratch across the paper. This could be like an ASMR video, but I'm not gonna go that route. Okay, so you can see I messed up here a little bit. Yeah, because it's hard to like continue the texture without like inconsistencies, right? So this looks slightly off, but whatever, you know. You know, you want to be like a critic of your own work, but you also don't want to like be so hard on yourself that you don't even do anything, which is why I'm doing this live stream. It's like a casual, whatever, mistakes happen, uh, just keep on going. But yeah, you want to strike that balance between like, I need to improve X, Y, and Z, but also I am doing this great in terms of, you know, A, B, and C, or whatever. I'm just using random letters at this point. So, and you can definitely like make this process easier if you draw on toned paper. But even then, you know, to get really the contrast, you have to kind of shade the background a little bit. Right. This is like super tedious, but what's nice about drawing on paper and just seeing your ideas come to life like this is that it gives you time while you're doing these strokes to think about other things, like, oh, you know, maybe not like how's your day or anything like that, but like, you know, like the design of this aircraft, right? While you're doing this, you can think about, how am I gonna model this fuselage? It's so round and nice. I could go out and probably buy a cigar. Well, I'm old enough to buy a cigar. I don't condone smoking, but if you bought a cigar, you could probably use that to model the fuselage, but I would not recommend that. That's gonna be one hell of an expensive fuselage. And plus, with the situation outside right now, I would not recommend that. Also, just smoking sucks, so don't do it. Alright, so I have kind of a preliminary light gray background drawn here. I'm probably going to shade in the underside of this object right here. So this edge area right here, right? So if I mark it out, show you guys the area that I'm going to shade. You know, I am finding this to be a little weird. This corner is a little, it's like, it looks fine, but it's like, it's like not a very elegant way to put it. I think on the Su-47, if you guys know that design, it's a real life fighter jet that has forward swept wings. There's like a little section right at the root that connects the fuselage to the wing. I think I'm going to add that here. It's like, it's called a wing guard, I think, or from my senior design class last year, I think it was called a glove. It's just like a fairing that connects like this structure right here, right? It doesn't have to be perfect, but this glove structure is a nice way to blend the wetted surfaces. Wetted surfaces just mean like the surfaces that are touching the air, which is not wet, but we call it wet, you know, to describe it. Yeah, so I think I like this glove idea. I'm gonna add that to my design. So you notice like this line is a little tough to erase because I pressed down a little too hard. So don't do that. Don't pull Y13A or Ben. Ben is my name, so you want to refer to me by that. That's cool too. So this edge is still gonna be here, but then again, edges aren't real, so, but this like conveys the idea, right? But if you really want to get into it, you can erase this line so that it barely matches the value of the background shading, and so it looks like a real object, you know, instead of like a cartoon, like there's an edge right here. It blends better into the background if you make it a little lighter, but I don't think I'm gonna try and perfect this drawing. I'm just really thinking about how to build this thing, to be honest. I don't know how I'm gonna do it. So that's like the other side, the wing glove. It's being obscured by the fuselage here. Yeah, the designer in me is thinking, you know, well, not designer by profession, but I'm just like going off on a tangent. I really like, as I mentioned Burt Rutan earlier, I really like how organic his designs are. Like the windows on some of his planes are definitely not like just rectangles or, you know, sharp shapes like, you know, on the Airbus A220. It's like on the, at least Canadian Canada Air or Air Canada. I am losing my presentation skills by the minute, but they have like a nice cockpit setup where it's like you have your nose, whatever, but it's like a sharp looking plane. I really like that, but I digress. Burt Rutan's designs are really nice because they're so organic. It's like, it looks like modern art, right? You know, that you have like ovals, small and large, all over the place, which, you know, must have taken a ton of time to analyze structurally, but it lets so much light into the cabin, and it looks pleasing to the eye because it's more organic looking. It's smoother curves and whatnot. So anyway, I think that's like a design direction I want to try and explore. It's more organic looking at things. Erase that. Yeah, I might do a little bit more background shading right here. Make the tail end here pop a little more, just to smooth out the background texture here. Okay. Fill in some of the missing areas. Honestly, like, I'm not used to this, designing with an audience. Design is usually a quiet activity where you kind of just think to yourself and reflect on what you have in front of you and where you want to try and get to. This doesn't look too great, but I like this drawing right here. I cannot state that enough. This is the concept I want to go with. Let's see how we're doing on time. We're at 84 minutes. That is 40 minutes away from 2 hours, so I can do this for a little longer. Yeah, we drew the gloves here that allow for air to smoothly flow at this corner. You know, what if we added gloves on top of gloves? Like, can you imagine that? Like going out in the winter and you're wearing gloves, like one glove and then a larger glove over your glove? Like, what? Anyway, what if you made it like a second compound glove here? Anyway, yeah, that's just an idea, but I don't think I'm gonna do that because that complicates things. And you know, these parts, they take a lot of time to manufacture, and that's actually why you spend a lot of time, actually, is if you can design the parts on paper and they're mostly paper and you have a printer, great. You know, that solves a lot of your problems. Like, that takes so little time compared to handcrafting every single part from scratch, which is what I usually do because I don't have like advanced automated CNC paper cutting machines, for lack of a better term. I just the way I do things when I make parts is I make one layout part, like a flat 2D shape, cut it out, and then use it as a stencil to trace, like, you know, the edges. And if it's a straight edge, I can use a proper ruler to make the line. But if it's like a you know, like a curvy shape, I'll just trace that shape that I just cut out onto the next part that I'm going to manufacture that's exactly the same as before. And the problem with that is tolerances, right? If you shift your pencil slightly or if you move it in slightly, and it's like going to be different. So definitely the way forward sometime in the future is to get like an automated paper cutter, right? That will save a ton of time in the build. Definitely like 3D printing is like an interesting thing that I want to try and explore. You definitely make really, really intricate mechanisms with SLA or PLA. I like the ones where it's like you have like a tub of liquid and you have a UV light curing the plastic underneath, because that's like a really high fidelity, high resolution way to 3D print things. I want to try and get one of those machines to be able to make moving parts. But you know, that's like dreaming about the future, you know. But yeah, this hobby can be as expensive as you want it to get, so trying to keep it cheap here so most people can do it. Pen and paper, pencil and paper, eraser here. I think I'm gonna start maybe sketching out some plan form shapes, some parts to lay on, you know, start actually building this thing. I don't know how far I'm gonna get with the build. I might not finish it in this stream. I might have to continue it in another stream. I'm not gonna promise tomorrow, but definitely gonna have a stream, try and get one every week on Fridays, so that I actually force myself to do something with regards to the design and building. Because I find it hard to stay motivated, quite honestly. It's really easy to just lie on the couch and watch Netflix. So, yeah. So I think I might want to start building. I don't know how I'm going to do this yet, but I'll figure it out as I go. So, now we get another sheet of paper. Paper's like my second favorite material in the world, second to titanium, which is like my favorite metal. So paper is great. Right, so the way things are here, I think I'm gonna draw the fuselage first and try and get a basic layout. Yeah, this would be like, you know, top-down view of this design. And that's gonna be like a cigar shape, basically, right? And the nice thing about this is, well, do I want to put a ton of effort into trying to get the shape right? That is the question. So if I do, then I would only draw half of this and then cut that out as a stencil, draw one side, trace one side, and then flip it over and then draw the other side, and then cut that stencil out as the proper stencil, which would take a lot of time. I have a better idea. How about I just, you know, how large do I want this to be, right? First of all, we need to figure out what the size is going to be. It's going to be this big, you know, wings coming out here, and then a tail here. Will that probably fly? Maybe. That is quite large, actually. So what if we take like, this is like a standard 8.5 by 11. 11's pretty close to 12, so if we just take like 2/3 of 12, which is 8. I like nice ratios. That's another thing about how I design. I like nice numbers. This is 11 inches, and we're trying to get to 8, right? This is a rough idea. If you really want to be really super strict about this, you would measure out this, which is 8.5. It's supposed to be 8.5. Please tell me it's 8.5. It is not 8.5. It is. Just kidding. It's 8.5. All right. So half of 8.5 is 4 1/4. This is where imperial units are great because you can just keep on dividing by halves, right? 1 inch, half inch, 1/4 inch, etc. It's really nice for making things, but it's terrible for actual science work. I will say, like, the real life aerospace industry uses imperial units, so get used to it. This is America. Anyway, just want to draw like a center line here for the fuselage. And so we know that this line is exactly in the middle because we constrained it to 4 1/4 inches here, 4 1/4 inches here, exactly halfway on both edges. So we know it's exactly straight and parallel to these edges if the paper's cut right? So this is why it takes a freaking long time for me to make things, because I check these tiny ass measurements. Sorry for swearing, but it's a little warm in here. It is 64 degrees outside. I'll take a sip. Alright, so I'm going to draw a point here, mark out 8 inches. And, like, sizing is a very, very fascinating subject in aircraft design because the properties all scale differently, right? So if you have a square that's 1 inch by 1 inch, and you double that to 2 inches by 2 inches, right? The length, x versus 2x, doubles, right? But the area is 4 times, right? Because you go from x squared to 2x squared, which is just 4x squared, which, that's 4 times your original area. And then for volume, it's another 2 inside of this, so it's going to be 8x cubed, right? Or whatever. So if it's two times as long, but you're looking at the volume now, it's going to be 8 times. So things scale differently is my point. And this gets even more complicated when you think about actual fuel and like energy. But we're not doing any of that because this is a paper glider. We're not designing a natural airplane. But how to size something? Well, as a once upon a time, I got a comment on this live stream that said, take a shot every time this guy says eyeball it. I think if you scroll back up far enough, you'll see that comment. Well, you should take a shot right now because I just kind of eyeball it. That's how I size these things. It's a lot easier than doing like a full-on optimization problem, which is how real-life designers at Boeing and all those other defense contractors, they do a lot of studies just on sizing, and it can take months. So that was a terrible way to draw like a fuselage. I definitely would not recommend that, but it's just a rough idea. Just get a feel for the shape. Alright, so how are we doing on time? We are at 95 minutes. I have 20 more minutes to go. Then again, I might stay longer than that. I might actually build this thing out in one session. So how do we want the tip to be? I think I want it to be blunt. This sketch shows a sharp tip, but I think I'm going to go with a blunt tip because it's probably going to be better in crashes. And these designs, they always crash because gravity is a thing, unfortunately. So I don't like how this is. Well, see, like in the original sketch, this was round. Or I don't know if I want to keep that because that's hard to make. Round shapes are nice. They're hard to make. So I'm going to go with a flat fuselage here. This is like where thinking about design comes into play, right? You don't want to make, you don't want to design something that you can't make. What's the point of it, right? But you also have to have like a goal to aim for. It's like, oh, okay, general shape like this. With 3D printing and other manufacturing methods, totally, yeah, go for a round shape because you can build that. But because I'm building things out of paper and straws and they don't like to bend in these neat ways, I'm gonna have to go with a straight edge here just to make it a little bit easier for myself. So this looks a little bit big in the back. I think I want to like thin this out a little bit. Right? This is like kind of a tapered shape. This is not completely blunt. This is like a very nice shape. I say nice, but it's like really up to my judgment. You'll develop your own sense of nice. You have your own experiences in making things. And that's where a lot of unique design traits can come to be, is just through your own experiences, combining your past learning, past experiences with new ideas. This is an interesting shape. It looks vaguely like a cigar. It's not like a proper fuselage like this, but alright, so I think I'm gonna start cutting. Let's see. Say I am trying to figure out my time here. 98 minutes. Let's go to 120, so that's gonna be 2 hours. Yeah. I'm just gonna keep on going until I feel like stopping, I guess. Find a good stopping point. Might do another live stream some other time, but alright, so this looks alright. This is just a fuselage sketch. So, using the power of symmetry, I am now going to cut just this edge that I drew, not the middle line. Line in the middle. There we go. Use your words, Ben. Alright, so this is a rapid prototype, so it doesn't matter too much what it looks like, I guess. I'm just gonna build something right here. Don't want to give myself a paper cut. That would suck. Use your week with a paper cut on a live stream. So this sheet is going to be all templates basically, so I can reuse this area here. It's not a big deal. So I need to make this easier for myself. So let's start cutting from the other side here. If you're watching this at a later date, well, hopefully you know that 2 times speed is a thing. So you can speed this up. But those of you watching live right now, well, I'm just gonna have to stick with this. This is why, like, I'm saying, like, keep this in a background while you're doing your own projects. That's like the most engaging way to interact with these live streams. And I'm gonna read the comments right now. If you have any questions, you can definitely ask them. I can't promise that I'll see them. Any benefits of forward swept wing designs compared to others? What lead size do you use? Just curious for the kicks. Yeah, what lead size? I use 0.5. It's relatively common, and it's cheap, I guess. Yeah, it's HB 0.5 millimeters. This pencil is the graph gear, or not graph gear, Pentel 500 or something. I'm not too familiar, I guess, but it is what it is. Just reading through some of the comments right now, so I'll just put this here. Benefits of forward swept wings. So, forward swept wings, first of all, they look cool, which is usually what I tend to go for because these designs aren't meant to be actually functional. They're supposed to be fun, and you fly them and stuff. But forward swept wings, in practice, they are good at maneuverability. They have nice stall characteristics where the root of the aircraft stalls first, and then the tip, so the stall propagates from the inboard towards the outboard, and that's very desirable for maintaining maneuverability and control over your aircraft. So definitely read like a Wikipedia page to go through the full details of that. Lead size, forward swept wing benefits. Thinking about getting a cry cut maker. Yeah, I mean, automation is definitely a plus, whatever you do. It saves time, is more accurate. So that's always a plus. Dude, you should rubber band launch the aircraft. It's a lot easier, more efficient. I wouldn't say it's more efficient. I would say, I probably would be able to throw aircraft higher than rubber bands, just for my own designs and whatnot. So if you want to launch your paper airplanes with rubber bands, feel free to do that. I am not really a proponent of that. I prefer hand launching. Although at some point I might build like an actual catapult, but that'll be a little bit into the future here because I'm living in an apartment right now. I don't have the proper, shop tools to create my own catapult. When it comes to designs, which ones have you wanted to revisit or refine the most? So right now I'm trying to build a second version of the Astra, which is, if you look back at some of my YX designs, they've all been generally the same. So I think I'm really into that canard and swept wing kind of configuration. I'm trying to currently reinvent or refine the YX10. Just put in more mechanisms and features and whatnot. So yeah, I don't know if there's any other comments at this time. Yeah, this is all the comments for now. So I'm gonna keep on going. I'm gonna cut this out. We're doing on time 104. All right, so I'm not gonna cut the center line here, but I will fold it and use the power of symmetry to my advantage. So, nice thing about rulers, right? I was talking about this in the beginning of the stream. You take a ruler, you line it up against the edge you want to fold, and then you Okay, gotta try and get underneath the other edge. There we go. I'm gonna use an X-Acto knife because it's sharp. There we go. Alright, and then you just take your other ruler. Well, I took this one, but it really doesn't matter what kind of ruler. With a shorter ruler, you just have to make sure you get this entire line. The longer ruler, it's a lot easier. I don't know why I just didn't do that earlier, but whatever. It is what it is. So, I folded it. I think this curve is generally okay. It's a little bit outside of the line that I drew, but it should do the job fine. And if it doesn't, well, I'm gonna make the other side, cut it out first, and then fold it in half and do any adjustments afterwards. That's kind of how I would do it to make it nice and symmetric. So this is a new way to make these things. In the past, I've always made a plane using a what's it called? Just a regular dart paper airplane, folded landscape with a 8.5 by 11 sheet of paper. So like this, you fold this in, and then you fold that in, and then you fold it in half, and then you fold it down, right? I don't know if that conveyed the message, but point is, I used a regular dart paper airplane and then added wing extensions to that to make designs. But now, you know, with a little bit more experience, I'm just gonna start building custom fuselages and whatnot. I feel like that increases the amount of things that you can do. No more limitations. I gotta check if there are any new comments. No comments at this time. Awesome. So I'm gonna cut this, try and match the line that I just traced out by folding it in half, and then, you know, tracing this symmetric line out. Do that. So it's not perfect, but the nice thing about symmetry is that you can get generally close enough, and then you can fold it in half after it's done being cut. And then you can do some trimming on the folded piece, which would make the cuts on both sides of this shape. Right? So this isn't perfect, but if I fold it in half, right, I can do some adjustments. I can cut 2 layers at the same time. Right, that's kind of a nice manufacturing technique. So you're just fixing both sides of this curve. I don't know how important this is. I think for the most part, I got the curve down pretty nicely. Yeah. All right, so this is a nice shape. It almost looks like an airfoil, but it's not. So, what are we gonna actually use for the fuselage? We can use cardstock. I feel like I want to test out a new material, which is just cardboard box. Which, you know, it's not like the type where there's like a space in between. It's like just flat sheets of recycled paper. Hold on, let me get a sheet real quick. Ugh. Anyway, you like cereal boxes? Because I like cereal boxes. This is from Cheerios. This video is sponsored by Cheerios. Anyway, just kidding. Not really. I am not being sponsored. But it'd be nice though, having a sponsor. But anyway, trace this stencil onto something a little stiffer to use for the fuselage. Right, and then you can just like feel where the edge is and then put down a line. And then, do the same, try and pin it in the same position. Try and get as much as possible. My hands. Whoop. So I shifted it, which sucks, but I think I can just barely make it out, right? The shape here. So now I am going to attempt to cut this. I don't know why I said attempt. I am going to cut this stiffer material as a base for the fuselage, just gonna cut. Alright, that's a nice curve. Just keep on going. If you're watching in the future, go at 2x speed. Save yourself some headache. Then again, I know some people like to have background noise, so this is also good content for that. Just keep it on in the background. Anyway. These scissors are more tailored for paper, I feel like. They're not heavyweight shears or anything. This is like standard paper and maybe textiles, but it's a little hard right now to use these scissors to cut cardboard. Anyway, I think I got it down mostly. Well, then again, this is a rapid prototype, so it doesn't have to be exactly perfect. Try and get it to be as nice as possible, but with time constraints and energy constraints, right? So we have a fuselage. Now what are we gonna do? I think we're gonna start to sculpt it. This is where the fun part comes in. So I have some straws that I can use. I think I'll just use one thin straw and probably need 3. This drawer. Oh my god, it's jamming. Alright, sorry about that. These are from Dunkin' Donuts. So, again, not sponsored. It's just nice to cite my sources, I guess. So, nice. Bad thing about this straw. I was gonna say nice thing, but it's not a nice thing. Bad thing about this straw is that it's cracked. So this is why I don't want to use a straw for a boom, is because sometimes they come cracked. When you get perfectly fine straws, sometimes they crack when they, get a load applied onto them. So they're really kind of unpredictable. I'm gonna cut this off because it's not that great. All right. Yeah. don't need all of that too. Right, that would be too long anyway. So let's get a sip real quick. All right, I'm trying to follow this design. I want to try and copy that. Try and model that, right? So I'm gonna do like a Astra style fuselage. So I might want to just triple layer, or yeah, put this down the axis, put 2 more here, and then 2 more on top of that, so a total of 5. So essentially what it'll look like in a cross section would be like 3 rings like that, and then 2 on top of that, which are the same diameter. It looks slightly smaller for some reason, probably because I drew it like that. And then you have a thin diameter straw on top that arcs all the way down, right, to form that nice spline. Now, essentially copying that architecture from the Astra. So I'm gonna try and do that with this prototype. I am nearing 120 minutes, which is about 2 hours. So I don't know if I should continue or save this for another day. What do you guys think? Is there any comment or anything? I'm just gonna read. Oh, no comments. Awesome. So I think I'm gonna go a little bit more. Let's say I end this stream at 7:30-ish. Yeah. Unless you guys want me to go longer than that. I think I'm gonna just stick with 7:30. Eat dinner at some point. That's a nice place to end, somewhere, you know, in the middle of the build, and then continue next week. Yeah, so right, so well, do we want to build the fuselage first or build the wings? Right, the wings are pretty important. So I think I'm gonna try and get the wings made so that they're ready to mount onto this. Yeah, that would be nice, right? If I get the wings, because it's gonna go through the middle. This is a mid-wing design, so we're not mounting the wing on the bottom of the fuselage, right? Like that, or on the top, like a C-130 or something. We're putting it straight through the middle. And this configuration is usually used in fighter aircraft, not cargo aircraft, because you need to put cargo in the middle. So cargo aircraft, usually high wing, stable, because the center of gravity is lower than where the wings are. And then low wing, this is also used on fighter aircraft, but not modern fighter aircraft, because this gets in the way of internal weapons bays, which are critical for stealth aircraft. So most modern airplanes use this mid-wing design, which I'm gonna go for with this. Well, it's either gonna be mid or low. I pointed to this, but it's gonna be mid or low because the way the wing is mounted, it's gonna go through this fuselage to be like super secure. I don't want it to like break or anything. And then, if it goes through here, whether or not it becomes a mid-wing depends on whether or not I build an underside to this, which I very well may not. I might just keep this flat. I might do something to cover this up, but it's going to be generally flat. Or I could spend extra time and try and make a cigar shape in this dimension, which would take a little bit more time, but I think I'm gonna try and get the wings done today. Well, we're at 2 hours, so oh yeah, I said 7:30, so whatever. Right, so what are the wings gonna look like? And this is a fun part of the project. If you have your main fuselage and you know what you're gonna do, let's just put the sketch over here a little bit. So you have your fuselage, and you can essentially just mount it on like a piece of paper here, right? And then imagine like how the wing is gonna come out here, right? So it's gonna be like that. So again, sizing is a whole field in and of itself, but we're just gonna go off the rough proportions that we sketched up in this initial drawing here, right? So in this drawing, it looks like this root chord right here for the wing is, let's see, from tip to tail, right? Or yeah, from nose to tail. This is 1, 2, 3, 4, roughly 4. So if we made it actually 1/4, it'll look kind of similar to that. And it'll be at a nice fractional value. Now, if you remember earlier, I said 2/3 of this near 12-inch, actually 11-inch piece of paper for the nose to tail length. So this is actually going to be 8 inches, and if we want to do 1/4 of 8, that's going to be 2 inches. So that actually works out really nicely. This is why it's super nice and important, for me at least, to have nice numbers and to use inches, not centimeters. I use centimeters also sometimes, but that's when I really want to like refine details because it's the smaller divisions. I know, like I'm mixing units, it's crazy, right? But you know, that's just how I work. But imperial units, they're super nice for dividing things, right? Taking ratios of things, taking proportions of things. Just from this just from this initial concept sketch, I can say that, okay, this root chord is going to be about 1/4 of this fuselage length. So, you know, if I made my fuselage length a nice value, like 8 inches, which is, you know, just like a hand wavy estimate for sizing. If I make it a nice number like that, I can easily divide that into 4, which gives me 2, and then I can place it. So placement, right? Where am I gonna place this thing? So I place my wing forward or aft. I think I'm gonna place it in the aft 3/4, right about here. Right, so that's gonna be like, so the front edge of that is gonna be at 4, exactly half of this, and then the aft edge is gonna be at 6 inches. Right, so that's halfway between the half point and the end. So everything is in proportion to everything else. That's another good rule of thumb for design, at least for what I do, anyway. All right, so you got 8 inches here, and this is really just gonna be an eyeball. So take a shot. Whoever commented, take a shot every time he says eyeball. So center line. All right, and then on that center line, we're gonna mark out 2-inch increments just for reference. The latter 2 are gonna be important. This 6-inch one is gonna be important. This 4-inch one is gonna be important. This 2-inch one, I don't know what I'm gonna put here, but probably it'll define some of the 3-dimensional curving happening. you know, it's important to mark that. This is 2, this is 4, this is 6, and then that's 8. But we don't have space to write there. So we have this marked out. Alright, so we want the wing to the main root, and that's not including the glove. So like the root itself extends here, right? Goes in and reaches the fuselage. So for that, I'm gonna do 4 inches. So we need to extend that out to the edge here. This doesn't help to have it in the middle. I mean, it does, but you know, the wing's actually gonna be out here. Let's just extend this. I am in fact eyeballing this as well. Looks relatively perpendicular to the center line, so we're good. Alright, so this is going to be 2 inches where the wing comes out and forward. Yeah. So what I like to do is you need to have like some material at the root. So like if you have like a wing like this, you don't want to just create this outer part, or you know, ignoring the glove. You don't want to just create whatever's outside of the fuselage. You want to create some material that overlaps with the fuselage itself. That way, when you anchor it down at the fuselage itself, it becomes a rigid structural assembly, right? It's like a cantilevered beam, if you will. So that's like represented by this. You know, you have a wall and a beam attached to it. This beam is actually inside that wall, right? That's how it's constrained. So for wings, we want to have that set up with the fuselage. So it'll make it sturdy. All right, so I have no idea what I'm doing. I'm just gonna draw this curve out. Right. Nice thing about this is you mark it right where 4 inches is and where 6 inches is. And then keep an eye on this point. Hold your pencil still. Move this down. Mark it down on the paper. That's exactly halfway. So line these 2 points up again. Do the same for this bottom. At the intersection here, place your pencil. Oh, sorry. Let me just center this real quick. Alright, so you're like this. And then you see that? You're at the intersection. You lift your pencil up a little bit. You let the cardboard slip out. And then you have a point right there. And then you have 4 points. And what can you do with these 4 points? You say, well, you just draw lines connecting them, right? Like that. Oh my god, I can't. Alright, there we go. You can see it now. Right. And then, what do we want to do from here? We want to make it forward. So this is a problem that I did not think about. Because it's forward swept, it's gonna go past what we have here. So I really should have angled it like this, but I don't feel like drawing this again. That is a dilemma. You know what? Fuck it. I'm just gonna draw this again. I just swore again on camera. But luckily, I marked this as not safe for kids to watch. So, if you're a kid and watching this, well, too bad. But, here we go. Alright, so we did it again. It's just at an angle now, because it's a forward swept wing. I totally forgot about that. So we have this bit here, which is like the anchor. and we want to make the foreswept wing. So how much sweep should we add, right? Now if we look at our initial concept here, we can't really measure an angle, at least, right? So what we can do is draw some triangles. Alright, so you have your main axis, right, and then you have your wingspan axis here. You just kind of estimate like this to this, how much that is. That's like 1, 2, 3, about 3. So if your hypotenuse of your triangle is 3 times your root here, then what's this angle gonna be? Right? So whatever this angle is, tan theta, or not tan, sine theta, there we go. Tan would be this side right here. So sine theta is 1/3. Theta is arc sine 1/3. There's a nice app that does that. So let me do that real quick. Let me just turn notifications off so I don't get any random stuff coming. So we want sine inverse of 1/3. Alright, so that's 19 degrees. 19.47, in fact. So, since I like to round things a lot, I'm just gonna say that's 20. Yeah, that makes sense. 20 degrees. But, you know, this is like going a little beyond what I normally do, but it's a good idea to do this to have an idea of what, you know, you're gonna want to set up your wing sweep angle as. This is gonna be 20 degrees forward of, you know, perpendicular to the fuselage. So this angle is 20 degrees. I like to round, so 20 it is. So I do not have a protractor. That sucks. Anyway, what you can do instead is okay, well, let's draw this edge down right here. Right? Alright, so you have this edge, and then, so we know that the triangle is like, you know, 1:3 ratio, right? So we have 2 inches here. Oh yeah, well, this doesn't depend on that. It's gonna be how long this is, how much to come out, how much to go forward, is dependent on the span. So what do we want the wingspan to be? Well, let's just eyeball it. Take another shot. Alright, so we want it to be about this big. Is that reasonable? That's, how big is that? That's like about 10 centimeters. Cool, 10 centimeters. See, I'm mixing units. Alright. 10 centimeters in inches. It's about 4 inches. 4 inches is a little bigger, and it's imperial, so I think I'm gonna go with 4 inches. So 4 inches out, right? That means how much do I need to go forward, right? If my wing is like that. So if you have 4 for the span, so that means this edge is 4 now, 4 inches. Now how much do I need to do for this, right? So we know that that's 20 degrees. This is 4 inches. So tan of 20 equals whatever we need over 4. So whatever we need is just 4 times tan 20. Which, let me calculate that real quick with my calculator. Oh, if you notice, this is one of my sketches for the YX10 Astra Mark 1. So, oh, I said I'm gonna go to 7:30. Damn it. Well, I'm getting into it, so I think I'm gonna continue a little more. So, we want to calculate how much forward we need to go. So that's gonna be just 4, 10, 20. Oh god, will it recognize that? Yes. All right, so that's 1.455, which is close to 1.5. So I'm gonna round to 1.5 because I like nice numbers. Unfortunately, rounding this to 1.5 and having it 4 inches out is not gonna give it exactly 20 degrees of forward sweep. But I like nice numbers, so we're just gonna go with that. So now we know 4 inches out and 1.5 inches forward. So that's gonna give us a shape, right? That's gonna give us a triangle, which is gonna look something like this, hopefully. 4 inches. Oh, no. 4 inches from the fuselage, not from the center line. All right, that's 4 inches. Now we turn it like this, eyeball 90 degrees, and then go forward 1.5. Yep, that's about it. So we want to connect this point right here with that point right there. I know this is a little messy, but it is what it is. I do what I want anyway. As long as I understand what I'm doing, all is good. Alright, so that's our leading edge. Isn't that amazing? Like, we just defined our wing shape using trig. We used math. Holy fuck. Anyway. So how much extra do we want the winglets to be? Let's see. From our concept sketch, we have this, which is approximately 1, 2, 3, 4, around 5. So 1, 2, 3, 4, 5. Yeah. So it's a fifth of the entire thing, and a fifth of it is at the wing tip, like beyond the wing tip, right? Does that make any sense? Am I confusing people? Hopefully not. Well, essentially what I'm trying to do is extend this shape out to accommodate for the winglets. I do not know where my eraser is. Dang it, it's right here. Alright, cool. So, yeah, so let me just write that down. 4 by that. 1.5 inches. Alright, so we're gonna need to extend this winglet section here. But by how much? This is gonna be 1/5 of this entire length, right? So that means, okay, well, if we reverse that, this is gonna be 4/5, whatever whatever this length is. And so if we divide this length by 4, we get what we want to extend it by. Cool. So, let's measure this. This is way too much math, to be honest. I normally don't do this, but just to be a little bit more accurate, taking extra precautions. So this is 4.25. It is 4 1/4, which is 17/4. That's a terrible number. Alright, well, that's really close to 16/4 question mark? So it's really close to 4 is what I'm saying. So if we made it 1 inch extension, it should be good enough. here, what I'm doing is I'm moving the ruler in a little bit so that this first inch here is going to be on that line. So if you do it like this, you might be at a slight angle and you wouldn't know, right? But if you move it to 1 inch and rotate it a little bit so that matching that original line, you're gonna be all set. You're gonna be Gucci anyway. So that's essentially the segment for the winglet. So it's gonna be one continuous surface. That's why I'm doing this. That's 2 inches. Nope, just kidding. It says 2 inches, but 2 minus 1 is 1, so this is actually 1 inch, which is what I want. Great. Now, about this taper, right? How much should we taper? I have no idea. Whatever looks right, I guess, right? So, this is gonna come out to here, but we don't want it to look too fat, right? This wing would be too fat. Whoa, okay, so I need to move this up a little bit. There we go. Let's see. Hey there, Ben. Finally joined the live populace. Hello, IVPAC Global. I watch your stuff too, so thanks for supporting my channel. We watched your test pretty in depth. Whoa, Trig, and to think most of the rest of us just fold and fly. Well, yeah, it's as complicated as you want to make it, right? And that's, true for hobbies and real life industry too. Those really big companies, they spend tons of money trying to R&D the perfect solution, right? And that's where you can get super detailed and create really cool things like stealth and whatnot. But for hobbies, it's really however much effort you want to put in, and that's dependent on the individual. So yeah, I just read some comments. I don't know how long I'm gonna continue this until. I'm gonna say 8:30. I said 7:30, and now it's 7:37. Or 7:37. So that's a number for the Boeing plane, isn't it? Yep. Sorry. I gotta stay caffeinated. I'm drinking some Coke right now, so. Actually, I'm gonna go turn on another light. Be right back. Alright. I am back. Now, where was I? I was trying to determine what the taper ratio is going to be. And for this kind of length, I have no idea. I'm honestly just winging it right now. Pun intended. So, this is 2 inches, I know that. So alright, this looks about right. So I'm going to mark that. How much is this? This is about 3/4. Actually, almost on the dot 3/4. Wow. So that's the nice thing about drawing, is that you can almost get a feel for these ratios once you do enough and have enough practice. And so like when you eyeball something and then you say like, oh, this looks about right, and then it's like this measurement almost exactly lines up with that. I did not intend for that, but it just happened to be exactly 3/4 of an inch. So that's really nice. I don't want to keep it at 3/4 of an inch, but I don't think the winglets are gonna continue this trailing edge here. I think this part out here is gonna be a little like a compound taper, so it's gonna taper a little more. So what's the ratio between this root here of the winglet and this, right? Another proportion. Well, 2/3 is a nice number. 2/3 of 3/4, right? That's gonna be half, so half an inch. So if we, well, let's see, we need a parallel line to this, right? So if we go out here, just eyeball it, then we draw this line, and then draw another line parallel to that, right? And then say, okay, half an inch off of this is going to give us that location right there. That to that is going to be the winglet. Now that looks to be a little big, to be honest. So, so this point is going to continue all the way to the root, which is right here. So now we have our first look at what the wing is going to be like. It's going to be pretty thin. Not sure if I should increase this or shrink the wingspan a little bit. This is interesting. Well, let's see. Well, what do we really want to do with this, right? This is like a nice taper. If we envision the aft portion of the aircraft, it's going to be like, roughly something like this. Right, tail right about here. So that, does that feel about right? Wingspan might be a little large. And then, so this tail portion here is going to be like a square block. I'm probably not making any sense right now, so I'm so sorry if you guys are watching this. It's going to be like a block here. It's going to come up, down, right? So is this in proportion? Like we're going, wings are going out to here, and then it's folding down. So I think this should be okay. It's just this wing right here looks to me, it's like a little, it's a little high for the aspect ratio. It's a little thin, so which is why I'm wondering if it's better to move this aft a little bit. I think we might need to tweak that. So if we were to do that, what would it look like? That would look too big, right? So I think the way it is right now, actually, it doesn't look right, but I'm hoping when it comes together, it'll look okay. Yeah, this wingtip is a little interesting here. So it's going to end here. I go to half an inch, but then keep that taper ratio. It's going to end here. And we have this root here. All right, so you know what? I think this is good. Good enough for a rapid prototype. So I'm gonna have to cut this out to make it easier to be symmetric, because I want this to be double layered, right? So it's gonna fold over this leading edge and then come back. To make that easier to manufacture, I'm going to truncate this rectangular area here. I'll like cut this off basically, just so that I can get a nice fold over area and not have any interfering geometry. So this region here is going to be attached to the fuselage. This is the actual wing, and this area right here is the winglet, and it's gonna fold down, which is experimental. I don't know how it's gonna perform, but it is what it is. So it's gonna fold down, and yeah, we can continue this, I guess, next week. This might take multiple builds. Actually, you know what? Like, if I do anything over the weekend with this build, I think I will just live stream again. I'm not gonna like stick to the Friday schedule. Well, I will do it definitely for sure on Fridays, but like anything else that is not on a Friday will be kind of just additional, in addition to the Friday streams. So yeah, I'll end this thing at 8. So let's set a timer. Set a timer for 14 minutes.
Okay, 14 minutes and counting.
Alright, so now it's 46. So 14 minutes gets us right to 8 o'clock. And then I'm going to cut the stream at that point. But if I do continue this tomorrow, I'll definitely stream it again. I might not do so much commentary. It'll just be like a work session. I'll just be quiet and be designing on camera, live streaming, I guess. But yeah, that's kind of the plan, because once I get started on a project, I usually do it to completion. So I'm probably gonna continue this tomorrow, but not sure if I'll do that yet. But definitely on next Friday I'll do another live stream. But yeah, let's see how far we can get until 8 o'clock. We have 13 more minutes. So, and then I gotta eat dinner and then chill. You know, it is a Friday night, so. But yeah, I like to hold these things on Fridays because it's chill, you know. It's like there's no work the next day, no responsibilities, and you can go as late as you want, but I'm gonna call it quits at 8. So. Alright, so we have our wing defined. We don't have enough area to fold over onto, which is unfortunate. I should have planned this out better. Hey, that's pretty neat. If you look at this, you know, it's forward swept 20 degrees, but it's almost parallel to this, which is, it tapers a little bit. Just an interesting little thing that I noticed. That's, wow. Alright, guess I'm good at eyeballing then. Sure. Alright, so I'm gonna cut this shape out and then trace a mirror image onto the other side, and then cut that, you know, the two-sided dual layered template out. And once I have that cut out, I am probably going to translate that onto cardstock, and then once I have it on cardstock, it's ready to be made into an actual part. Right? So I think I'm gonna try and cut this out real quick before 8 o'clock. Alright, so you know what? I actually have a tool that I am not using right now. I should be using it. Alright, so like I said, this hobby is as expensive as you want it to be. So what I have right here, I'm just clearing up some space, is a cutter. Now this can only cut straight lines, but most of my designs involve straight lines. So it is all set for what I'm about to do. So just gotta line it up with the wire in the middle. It might be hard to see. but there is a wire, if you notice. There's a bunch of shadows and whatnot, but it's a metal wire that you can line up your piece that you're about to cut. And then, so now I'm aiming up the leading edge. Looks about right. Shifting it, tuning that, getting it right. All right, this looks good. And then cut. So that's saved, I don't know what, 20 seconds. Reset this. All right. Looks about right. Oh, all right. Yeah, that was awkward for my hand. Anyway. Wow, that was a clean cut. I'm just gonna do it for this tippity tip area here. Damn it. All right. All right, that was quick. It's a very nice cut. Right. It's the forward swept bit where the taper changes. This last bit, I could just use a scissor. So knowing what to use, what tools to use for the right jobs, saves time. For these long edges cuts, they're really nice. For these shorter edges, it might be quicker to just use scissors to quickly trim it down. All right, so we have our wing. Yay! All right. I'm gonna keep that cutter thing right there. So, unfortunately, the reason why we're doing this is because we ran out of space on the other sheet that I cut this template from. So we want to make another template where it's like, this shape right here, but then also the mirror of that. And the reason why we want it to be attached to each other is to have a double-sided template, right? So this thing that I'm about to make, where I trace this and cut it out, that's a template for, that's going to be another template for the official part, which is going to be a cardstock piece of material, just because it's more durable. Years ago, I did actually just use printer paper, but it ended up being not structurally sound. So that's why I am switching materials sorry, I'm just reading the comments. Switching materials to cardstock, basically. Practically supercritical. Although I doubt wing warping is an issue on this scale. Yeah, forward swept wings are interesting. On this scale, at this low of a Reynolds number, I think it should be fine though. Yeah, the problem with forward swept wings, if I can illustrate properly with my made fuselage and my wing here, is that when you're in flight, your center of lift is right about here, and your plane is at an angle of attack. So to generate lift, the wing needs to push up, right? But it's also because the center of lift is out here on a forward swept wing, pushing up means that you're also creating a ton of torsion in this wing, right? You're like pushing it like that, but then your wing tends to want to, if air is blowing, it wants to bend like that. So that's a real life issue that forward swept wings deal with. But those problems can be mitigated with advances in material science, right? So things like carbon fiber, right? Carbon fiber, if you weave it correctly for a design like this, its anisotropic properties, which means it's not like a metal where it reacts, tension and compression in different or in the same way in all directions. For carbon fiber, if you weave it properly, you get anisotropic properties where you can actually convert some of this torsion into bending. And composites are a whole nother can of worms, so to speak. It can get really complicated trying to get the weaves to be at the right, angle to each other, and having the correct amount of layers, having layers be symmetric on both sides. It's a whole field of research. But to mitigate wing twisting and in forward swept designs, NASA with the X-29 did end up using composites at one point, actually for all of the program, actually. So that's how you deal with aeroelasticity and the tendency for the wing to bend back. Anyway, I think I'm just gonna trace out the shape real quick and then call it quits for today. So I am maximizing the amount of paper, or minimizing the use of sheets of paper by making the most out of the area here. So I'm forcing this trailing edge of the wing planform to be along the top edge of this piece of paper. That saves me time because I don't have to cut this edge, and it also saves space for the rest of the stuff that I need to trace, right? So it saves paper and saves manufacturing time. I just traced that one. Oh my god, I got 3 more minutes. Can I do this? Alright. And then this right here. And then this right here. This right here. Alright. Nice. So I have that. So what I could do at this point is I could cut out these edges and then fold it over and then trace it, which, now that I think about it, it's not a terrible idea, but I already have this plan form, so I can save some time and directly trace this out. The thing is, you have to align it properly, right? I think I'll do a quick check. So like after I trace this out, I will cut this side first and then fold it over to see if it matches. If it doesn't, well, I'll just use the second method. But honestly, this is like, God, I think I'm like losing it a little bit. I've been on live stream for too long. I need a break. I am tired. Anyway. Yeah, you want to trace that bit out there. Alright, so we have that. And now we can use our paper cutter machine to save some time. Alright, so we're just gonna do a rough cut of this outer edge right here. Nice. Oh, that was a little rough. Oh well. So now we're just gonna cut this bit right here. Right, doesn't matter because we're not gonna use that bit of paper. just cut it off. Just feel free to do that. I'm cutting that. All right, it's time. All right, I'm just gonna cut this part out and call it quits for this stream. This is my first design session stream. Might do one tomorrow, might not, but definitely next week on Friday. All right, so this is it. This is the template. So if you fold this in half, you'll have a wing, and you'll have the winglets too with it, which you can fold and do stuff with. But this is the template that I'm going to use to transfer onto a cardstock sheet. And I will definitely do that. I feel like it's harder to start projects. So now that it's started, I have some pieces going. I feel like I can continue this relatively easily. Coming soon. So yeah, this is the fuselage, this is the wing. Probably gonna continue building this either tomorrow, but you know, if not tomorrow, I'll definitely do it next Friday. So thanks for tuning in. We got a lot done today. Did a sketch and manufactured some basic parts. Awesome. Well, talk to you guys soon.